But remember, root 3 times root 3, that's the same as root 9 is just the whole number 3. Root 2 times root 2, that's just the whole number 2. So what's happened here, whenever we have conjugate binomials, we are eliminating our radicals completely. So our answer is going to be a whole number. 4 times 3 is 12. 16 times 2 is negative 32. So our final answer is negative 20. And this is not just a fluke. Whenever you have conjugate binomials, so binomials that illustrate an opposite scenario, you're always going to have a whole number as your final answer. Okay? So they come in handy for, we have 2 more situations with radicals. And remember, this is all just kind of, up to this point, this has all been review of skills you already know. Now we're going to go on to, for the next 2 slides, a concept that you don't know yet. And that's radicals situations where you have radicals in the denominator. This particular question, when you have a monomial, that just means one term, it's not difficult to solve. Yep. The problem when you have a radical in the denominator. The problem with this is, remember I told you that radicals are kind of like half a number, right? So this equation, when you have a fraction, it's like someone standing with just one leg. It's not really a secure number, and it's bad grammar in mathematics to have a denominator with a radical. So whenever you have that type of situation, you want to eliminate the radical, and you always need to have a whole number in your denominator. That's always, always, always the case. So in order to get rid of that radical, we're just going to multiply both numerator and denominator, not by the whole thing, but just by the radical that's giving us the problem. So we're multiplying both numerator and denominator by radical 5. Do not multiply by 4 root 5 because that will not give you the right answer. The whole purpose of this is just to get rid of the bad form and totally eliminate the radical in my denominator. So root 5 times 1 is just radical 5. 4 times, remember there's a 1 here, so 4 times 1 is 4. And root 5 times root 5 just gives me the whole number 5. So my final answer would be root 5 over 20. No longer, these expressions are equivalent, but this is better form because there's no radicals in the denominator. Now, you will be getting questions in your unit guide that look something like this. If I had the same problem, actually let's get to that for the next slide. Here again we have a radical in the denominator, but now we have a binomial. That totally changes things because I can't just multiply by root 6 or root 3. I actually have to multiply the denominator by the conjugate, which is another binomial. So this time you have to multiply both your numerator and your denominator by the conjugate of 2 root 6 minus root 3, and that would be 2 root 6 plus root 3. Both the numerator and the denominator have to be multiplied by this conjugate. Okay, so the numerator, you're just going to do the distributive property. So I'm going to take 5 and multiply it by 2 root 6. Separate by an addition sign and take the 5 again. Take the 5 again and multiply it by root 3. So the numerator is pretty easy. For the denominator, you actually have to do FOIL. So I'm going to need some room. So I'm going to take my first terms, 2 root 6 multiplied by 2 root 6, plus 2 root 6 multiplied by root 3, plus 2 root 6 multiplied by negative root 3, and my last terms, negative root 3 times positive root 3. So all of that is FOIL. However, we don't really have to solve the middle two terms. Those are completely going to cancel each other out. So I'm going to write my numerator down. 5 times 2 is 10 root 6, plus 5 times root 3 would just be 5 root 3. And my denominator, 2 times 2 is 4. Root 6 times root 6 is the whole number 6. And over here, negative root 3 times positive root 3 is just going to give me minus 3. Final answer, 10 root 6 minus 5 root 3 is going to be, 6 times 4 is 24. 24 minus 3. And when you subtract 24 minus 3, you're just going to get 21 as your denominator. Okay? So this is just FOIL from the original question, the original denominator. Obviously, this is going to be the hardest part of your unit guide, so you're going to have to pay attention. Yep. But the conjugate, yeah. You have to, because it's a binomial, you have to multiply binomials by the conjugate, okay? One thing that I want you to pay attention to, if, for example, I simplified and I got something like this, 10 root 6 plus 5 root 3 over 10. If I got a question like this, notice on the answer that we did get, 21 is not related to 5 and 10 at all, so I can leave the question like that. However, over here, we can simplify further. And the reason for that is, if I take the greatest common factor out of my numerator, what is my greatest common factor between 10 and 5 going to be? 10 and 5. What's the greatest common factor, Evelyn? 5. So if I take a 5 out, I can actually factor this. This will be 2 root 6 plus 5 divided by 5 is just 1. So 1 root 3 all over 10. You can only cancel this denominator by the greatest common factor if it's been factored out. So 5 goes into 10 twice. So my final answer is going to be 2 root 6 plus root 3 all over 2. Okay? So most of the time, if you are paying attention, you should be able to factor your numerator and cancel it out with your denominator. You're not always going to have that situation, but most of the time on a test, on an assignment, you're going to have some situation where you have to cancel out.